So, hi everyone. In yesterday's class, we studied about ellipse, definition of ellipse, and then standard ellipse and terminologies related to them. So in today's class, we'll study about position of a point with respect to ellipse, chord joining two points, equation of tangent in different forms, equation of normal, and director circle. Okay. Okay. So now uh, let's do this. You guys try this question. The line passing through the extremity A of the major axis and extremity B of the minor axis of the ellipse meets its auxiliary circle at point M. Then the area of the triangle with vertices at A, M and the origin O is. So here I'll just draw an. This is x square upon 9 plus y square upon 1 equals to 1. This equation. Okay. So this will be the ellipse for that. A is greater than B here, right? So that is why this will be the ellipse. And what it is saying, the extremity of the major axis, which is this point, and the extremity of minor axis. Okay. So this is the line. This line passes through the auxiliary circle. Auxiliary circle will be something like this. So you have now this point is shown as M. Okay, so the area of the triangle with vertices A, M, and O. A is where A is the extremity of major axis. This A, M, and O. So this is 0, 0 origin. This is A. This point is A. A will be what? A, 0, which will be 3, 0. We just have to find this point M. You have to find the point M and then you will get the area. So you know this line equation, right? You know this point. You know this point is what is this point? This is 0, 1. So you can find out the line equation, and then this line is passing through the auxiliary circle. You can find out the point of intersection of the auxiliary circle. What will be the auxiliary circle for this thing? Auxiliary circle will be x square plus y square equals to r square, and r will be this radius 9/4. A square, sorry, this will be 9. This is the auxiliary circle. So what is the equation of this line? y2 minus y1 upon x2 minus x1 will be 1 minus 0 upon 0 minus 3. This is the slope, which will come out to be minus 1 by 3. Now you can find out y minus 0 equals to m into x minus 3. So this becomes y equals to minus x by 3 plus 1. So this becomes 3y plus x minus 3 equals to 0. So you put this thing and this, and then you find the values of x. You will get two values. This will mean this point and this point. So you can find out using any value since both are symmetrical. Okay, let's move ahead. Okay, now we have to determine the position of the point with respect to the ellipse x square by a square plus y square by b square equals to 1. So there can be these three scenarios, right? Where the point will be first, it can be outside the ellipse. Second, it can be on the ellipse, and third, it can be inside this ellipse. So for all these conditions, consider for on the ellipse. Okay, when it is on the ellipse, that means it is satisfying this equation. Consider for this point on the ellipse, we have x comma y. So this x comma y is satisfying this ellipse equation of the ellipse, right? So that is why this x comma y will satisfy this, and hence x square by a square plus y square by b square minus 1 should be equals to 0. If this is the condition, then the point is on the ellipse, correct? What about outside? When the point is outside the ellipse, when the point is outside the ellipse, okay, so we have to guess through this value itself. So consider this point now, this, let's say we say p comma q. Okay, so now p comma q will satisfy this equation, but it will be like this: p square by a square plus q square by b square minus 1 should be greater than 0. If this is the condition, then point is outside the ellipse. Similarly, for this point, let's say you say h comma k. So h square by a square plus k square by b square minus 1. When this value will be negative, and then the point is inside the ellipse. So these are the three conditions. First, when this value is positive, you can say that the point is outside. When this value is equal to 0, you can say that it is on the ellipse. When it is negative, you can say it is inside the ellipse. Okay, so if you remember these three conditions, you can say whether the point lies on the ellipse, inside the ellipse, or outside the ellipse. So here, now, here you can see that for a line, this line a line can be drawn to the ellipse in three ways. Okay, one will be that it will always be outside the ellipse. One, it touches the ellipse and leaves touches the ellipse. So when it touches the ellipse, it becomes tangent, right? And other, after this, the third thing is it cuts the ellipse. Cuts the ellipse at 2 points. Now, condition for consider this line to be y equals to mx plus c, right? If this line is y equals to mx plus c, now we have to determine whether this line can be a tangent to this ellipse or not. So this line y equals to mx plus c, x square by a square plus y square by b square equals to 1. This is our given ellipse. Okay, this is our given ellipse. Now this y equals to mx plus c will satisfy this line, right? This ellipse. Okay, so now we'll start from here. I'm just writing x square upon a square plus y is what? Mx plus c whole square upon b square equals to 1, right? Why I have written substituted y equals to mx plus c is because this line, when it will be touching the ellipse, then also it will satisfy for 1 point, and when it will cut the ellipse in 2 points, then also it will satisfy the ellipse at 2 points. So that is why I have substituted y equals to mx plus c into this to find the values. Now this will become x square bx square plus, see here, we'll expand this will become m square x square plus c square plus 2mxc equals to, we take LCM, sorry, this will be into a square, and this will become a square b square here. Okay, we already took LCM a square b square, we multiplied it here, so 1 becomes a square b square, and then b square multiplied by x square and a square multiplied by this part. Okay, so now this b square, now what it becomes, b square x square plus a square m square x square plus 2mc a square into x plus a square c square minus a square b square equals to 0. So this is, what is this? B square plus a square m square into x square plus 2mc a square x plus, if you take a square common, this becomes c square minus b square equals to 0. Now you can see here that this is a quadratic in x, right? So if you want your line to be tangent, that means you have only one root. It is touching the ellipse at only 1 point. That is why here it is touching the ellipse at only 1 point, and hence that is why you have only one root for this equation. So to have one root, that means it will, the roots are real and equal. So when are the roots real and equal? When b square minus 4ac is 0. When b square minus 4ac is 0. So what will be b square minus 4ac? This will become 2mc a square whole square b square minus 4 into this ac, a square c square minus b square into b square plus a square m square. So after solving this, you will get c square equals to a square m square plus b square. Okay, so this is the condition of tangency. This is the condition for the line y equals to mx plus c to be the tangent to ellipse x square by a square plus y square by b square equals to 1. So when this condition is satisfied, then we can say that the line will be a tangent to the ellipse. Okay, and also you can remember the point of contact. The point of contact will be plus minus a square m upon under root of a square m square plus b square, comma minus plus b square upon under root of a square m square plus b square. So this is the point of contact. This is the x coordinate and this is the y coordinate of point of contact. Okay, so I hope you guys understood. So this is the point to remember. Okay, these point and this is something to remember, x and y coordinates. Okay, condition of tangency and the point of contact. All right, now let's see the line 3x plus 5y equals to k touches the ellipse in if the value of k is. Okay, so first of all, this line is given as 3x plus 5y equals to k. Let's reduce it in the form of y equals to mx plus c. Okay, so to do that, what I'll do is I'll write 5y equals to minus 3x plus k, right? So it will become y equals to minus 3 by 5 into x plus k by 5. Now it has become in the form of y equals to mx plus c, right? So this we already know what is the condition for, and what is the condition for a line y equals to mx plus c to be the tangent or to touch the ellipse. The condition is c square equals to a square m square plus b square. Okay, so here to get these values of a and b, we have to reduce this ellipse into the standard form. So that we'll do how? We'll write 16x square plus 25y square equals to 400. We'll divide throughout by 400. You will get x square upon this will become what? 16 by 400, how much it is? 16 to the 32, 8, 25. This becomes 25 plus y square upon 16 equals to 1. Okay, so this is the standard reduced form. So here a square is 25, b square is 16. Okay, so you get a square, value of a square and value of b square. Now we just use the condition of tangency. What is the condition of tangency? C square. C square, what is C? C value is k by 5. K by 5 ka whole square equals to a square into m square. A square is 25. M square is minus 3 by 5 ka whole square plus b square. B square is 16. Okay, so you get k square upon 25 equals to 25 into 9 by 25 plus 16. This gets cancelled. This becomes 16 plus 9, 25. So you get k square equals to 25 into 25. The value of k becomes plus minus 25. So this was easy, right? You just remembered this condition of tangency and then this was very easy to solve. So the answer is C, plus minus 25. I hope all of you guys understood this. Let's move ahead. Now Now here, do you guys know what is the parametric coordinate of an ellipse? So this point, let's say P is A cos alpha comma B sin alpha, and this is A cos beta comma B sin beta. Okay. So for an ellipse x square by a square plus y square by b square equals to 1, you have to remember the parametric form, which is a cos theta comma b sin theta. Okay. So this is the parametric form of an ellipse. So the equation of a chord of an ellipse joining two points p of alpha q of beta on it is equal to this. Okay. So when you try to find out the equation of this chord, okay, this chord equation of this chord, you will get something like this: x upon a into cos alpha plus beta y2 plus y upon b into sin alpha plus beta y2 equals to cos of alpha minus beta y2. So you can solve this and prove also, these 2 points, the coordinate of these 2 points. You have to find the slope and then use slope point form to find this thing. Okay. So let's not waste our time and just try to remember this formula. So what is this formula about? This is the equation of a chord joining 2 points on the ellipse, and those 2 points are given in parametric form. Then you have to use this thing. When you have to use the parametric form of coordinates, then only you use this. Otherwise, you don't use this. Now, point form. So you all remember this denotation, right? S1, T, and all those things we studied in previous chapter. So equation of tangent at point x1 comma y1. So this is the point. This is the point x1 comma y1, which is shown over here. Right. This is the point x1 comma. So this can be obtained by replace. Remember square by x1, y square by y1, and x by x plus x1 by 2, y by y plus y1 by 2, and xy by xy1 plus x1y upon 2. So these are all replacements which are necessary to find the equation of tangent in the point form. So this we have already studied, right? So this is the equation of our tangent. So let's not forget about that. So similarly here, earlier this point was x1 comma y1. Now this point is what? A cos alpha comma b sin alpha. So you remember the equation was x1 by a x1 by a square plus y1 by b square equals to 1, right? So here instead of x1, what is given? A cos alpha. So I'll write x into a cos alpha upon a square plus y into b sin alpha upon b square equals to 1. So this a square gets cancelled, b square. So we get x cos alpha by a plus y sin alpha by b equals to 1. So this is how we get the equation of tangent in parametric form. Correct? I hope you guys are understanding this. So this is the standard. By using these replacements, we have already studied in conics. You can use these replacements in every conic. If even if you study parabola, if you study hyperbola later on, or you study a circle, if you use these replacements, then you will get the equation of tangent in point form. Okay, equation of tangent in point form by using these replacements. Now in parametric form, what we have done is we have used the equation of tangent in point form. We have just used the coordinates in the place of x1 comma y1, which is given over here. Correct? And then we got this equation. See, you can see this equation and this equation is same. So you have to find it like this. Okay. Now slope form. Now the equation of, you already know, y equals to mx plus c is a, for this line to be tangent, we already studied c square is equals to a square m square plus b square. So C should be equals to plus minus under root of a square m square plus b square. That is why the equation in slope form becomes y equals to mx. Instead of c, we will write this thing now, plus minus under root of a square m square plus b square. So this becomes the equation of tangent in slope form. So as we already discussed the point of contact, the point of contact, which is this point of contact? This point of contact is here. This point, this point, this point, and this point. Right? See, you can see by using, by changing this plus minus and minus plus, and either two changes you can make. Here you can make two changes, so total permutation 2 into 2 4, so you can get four different points. So which points are represented by this? Here you can see, here this is 1, this is 2, this is 3, this is 4. So all these points are represented by this thing. So that is why this is very important to remember. You guys should remember this. Okay, make sure to remember this point of contact. It will be useful in questions. You can directly use the formula and find out the answers. You know for which condition this point of contact has been given, right? When an ellipse, when a tangent is drawn to the ellipse, this is the tangent point. So then you can find, or you have been given a line y equals to mx plus c only. This is given as y equals to mx plus c. Okay. Now you have to find the point of contact. So this you can use this and find the point of contact. Now the locus of the foot of perpendicular drawn from the center of the ellipse on any tangent to it is. So first of all, let's see which tangent, sorry, what is the equation of ellipse? X square plus 3y square equals to 6. X upon 6 plus y square upon 2 equals to 1. So this is the equation of ellipse, right? This is the equation of ellipse. So what is the equation of tangent? What is the equation of tangent? So first we will draw the ellipse. First of all, let's draw the ellipse. The ellipse will look something like this. Now any tangent you draw any tangent to this ellipse. Foot of the perpendicular from the origin will be like this, something like this. Okay. So the equation of tangent, any tangent, will be what? x1 by a square plus y1 by b square equals to 1. So this will be the equation of any tangent or is there any other form of tangent that we can use? क्या हो गया? Uh, to solve this question, see the equation of the ellipse has been given as x square by 6 plus y square by 2 equals to 1. Okay. Now we know that any tangent can be written as either this x1 by a square plus y1 by v square equals to 1, or for better information we generally write that tangent y equals to mx plus under root a square m square plus b square, right? So now the equation of the ellipse will be what? Y equals to mx plus under root of 6m square plus 2, right? A square value is 6, b square value is 2, so we have just substituted that. Now equation of the line passing through 0 comma 0 and perpendicular to this line. Okay, so this line is our tangent. Now we have to find, see, this is our tangent line. Okay, so this line is given by this thing. Now you have, if we knew the slope of this line, then this line is perpendicular, foot of the perpendicular line. So that is why the equation of the line passing through y minus 0 equals to 1 by m into x, right? This will be the equation of minus x upon m. So m will become minus x upon y. So this is the equation of the line passing through origin and perpendicular to the given tangent, right? So now we'll use this equation in 1. This, let's say this is r1, so this is our 2. So this result we will use in 1, correct? Because this and this are passing at this point, right? Where the ellipse is, where the tangent is touching the ellipse. Hence we will get what? Y equals to minus x by y into x plus under root 6 times of x square by y square plus 2. Now if you like if you this becomes y square equals to minus x square plus 6x square plus 2y square iska root, right? This becomes y square plus x square equals to y square plus x square ka whole square equals to 6x square plus 2y square. So this is the locus that we are supposed to find. So as you can see in the previous slide, what is the answer? See, we got this x square plus y square whole square equals to 6x square plus 2y square. See, x square plus y square whole square equals to 6x square plus 2y square. So A was our answer, right? Okay. Okay, guys, so this is it for today. Thank you so much for your time. Have a good day.